All right, the last video we kind of had to rush through at the very end, okay? So we were able to find this particular equation that modeled the data, all right? So I'm going to go to y equals, all right? I'm going to clear out everything, show you how to type everything in, okay? What we did is we took some actual information for problem number 1. We review kind of what we did here. We took this information right here. We made January number 1, we made December number 12, and we used our stat editor. So I made stat, enter, and we took all those temperatures. There's January, there's November, December is just below it, if I scroll down. Took the temperatures, and we made a graph of the data, okay? What we were trying to do is we're trying to find a model, basically a sinusoidal function that modeled this particular set of data. And the model that we got, you can see how we got that information in the last video. It's 22.5 sine, and we did pi over 6 theta. But to type that in the calculator, you can do pi divided by 6, and instead of theta, we put x. Then we figured out our c value was 2/3 pi, so 2 pi divided by 3, and our midline was a 54.5. Okay? So right here, our midline was y equals 54.5. If you don't know what that is, you can look back at the last video. And I hit graph. And what you'll notice is we made a model that actually basically goes through all of that data pretty closely. All right? All right, so when it asks us to compare, for example, when it asks us to compare what is the average temperature in our model and how does this compare to the actual average? Well, in July, what was our actual? In July, it was 77. Well, let's go to our table in our graphic calculator. Second graph, let's look at our table. At 7, hey, 77. So they actually ended up being the exact same for that model. Okay? But in answer choice F, it says, according to your model, what is the average daily temperature in December? So you go to your model. December is month 12, right? So go to, there we go. We're going to scroll down to what? Month number 12. All right. Oh, went past it. So right here, at month 12, we're at what? 35, basically 35 degrees. So you would write down for that answer, according to your model, what's the average temperature? You'd write 35 degrees. How does this compare with the actual average? So you go back up to the actual average and you go, well, the actual average is 37 degrees, so our model was 2 degrees less than the actual average. Can you actually write that answer in complete sentences? It's not difficult. Okay? And that allows you to be able to compare it. Now here's kind of a cool thing in our graph. You guys see the number 13? Number 13, we get back to what? 32. What's the number 13 represent? January of the next year. Interesting. Look how it keeps going. That's going to be, 19 is going to be July of the next year, right? So basically this model, everybody, this model continues to go on forever. So watch what happens. I'm going to change the window. And let's go, instead of from 0 to 12, let's go from 0 to, say, 25. All right, so go from window, X max, let's go 25. And you should see the same pattern, what? You see how our points stop here, but that what? The sine graph continues to go on forever. All right, so this is just a model of a prediction of the temperatures from month number 1 in January to month 12 in December. So hopefully by making the graph a little bit bigger, you can see how the pattern